This is going to be a introduction to roots and radical expressions. So our essential understanding is corresponding to every power there's a root. Just like we've been dealing with square roots, we're now going to get into the third roots, the fourth roots, and the fifth roots, and so forth. So I give you an example. 5 squared equals 25, therefore 5 is a square root of 25. And 5 is also a cube root of 125. 5 is a fourth root of 625 and fifth root of 3125, and so forth. So what does that really mean? It means that if you have a to the n equals x, and you want a, you go to the nth root of x equals a. If you're a little confused, I'm going to give you some concrete examples, but before we do that, you have to know a couple rules. A couple rules say that if a to the n equals b, a and b are real numbers, n is a positive integer, then a is an nth root of b. But if n, your index, is odd, there's only going to be one real root. And if n is even, you're going to have the two solutions, both positive and negative, because when we were dealing with solving with quadratics, obviously the square root of 4 is both plus minus 2. So I summarized the abstract into something more concrete. So if your index is odd right here, and you have a negative number inside the radical, it's going to equal a negative number. If your index is odd, and you have a positive number inside the radical, your answer is going to be a positive number. If your index is even, but you have a positive, you're going to have plus minus that number. But if you have even as an index, 2, 4, 6, 8, a negative number, there's going to be no solutions that are real. You have to know that we're not going to be using square root anymore, unless we were dealing with a square root. We were going to say the word radical. The radical is actually the symbol that we've been drawing. That little check mark is the radical sign. Anything inside that little v, the n here in blue, is called the index, and anything inside the radical is called the radicand. And that transfers to a fraction exponent. We're going to get to that in 2 sections. So don't worry about the equivalency, but it's good to know. Something that you also should know, that if you don't see anything in the index, it's 2, because just the radical sign alone with no number in the index means square root. So let's do a couple examples. So cube root. Cube is 3. So they're looking for x to the third will equal 0.008. So going back from the previous slide, we're going to take the third root of 0.008 to get x. So how do you do this on the calculator? So let's go to our TI, and we want the third root, so we're going to go to hit 3, then we're going to hit math, then we're going to hit this number 4. Actually, we're going to hit number 5 because we have the x in the index. And we want 0.008. Hit enter, and we get 0.2. So equals 0.2. So 0.2 raised to the third power equals 0.008. I'll do one of the fractions. Let's do the negative also. Might as well. So let's do the cubed root. We want x to the third equals negative 1,000, which means we're taking the cubed root of negative 1,000, which equals, going to our calculator, we're going to hit 3, math, 5, 3, math, 5, and we want negative 1,000. And we get negative 10. So the cubed root of negative 1,000 is negative 10. And the last one, we're looking for x to the third power will give us 1 over 27, which means we're doing the third root of 1 over 27 will give us x. So we're doing, again, the third root, math, 5, and we want to distinguish that it's going to be 1 over 27. And we get 0.3 repeating. To get that to a fraction, it's math. Enter, enter, which is 1/3. So x equals 1/3. So what are the real fourth roots of 1? So we're going to have we want x to the fourth, which equals 1, which means we want the fourth root of 1, which equals plus minus 1. The fourth root of negative 0.0001 is equal to no real roots. Again, you have to remember that index even, number inside is negative, cannot have any real roots. And the last one, we want the fourth root of 16 over 81, which is saying the fourth root of 16 and the fourth root of 81. You can put it all underneath 1. We'll do the fourth root. So it's 4 math 5 16 over 81. And we get 0.6 repeating, so we turn that to a fraction. 2/3. 2/3 plus or minus. So we can do what is each real number root. So for the third root, you just use your calculator and you're going to get -3. The fourth root of a negative number is going to be no real roots. And then this becomes the square root. Remember, it's 2, nothing there, means square, so it's really the square root of 49, which is plus minus 7. And then the square root of -49 is no real solutions, or no real roots. Last rule that we have to realize is for any number, a to the n and a to the n in your radicand, if a is odd, you don't have to worry about absolute values, but if a is even, you have to do the absolute. Basically, I have to summarize it, is if your index is even, and after you simplify and you have an odd exponent, you have to put the absolute values around it. So let's simplify. Index is even, so the square root of 16, basically square root of 16, the square root of x to the 8, square root of 16 is 4. Here we have x to the 4th. So we don't need to put any absolute values around it. We have to put absolute values around the 4. So here 3 goes in the 6, so we're taking the third root of a to the 6 times the third root of b to the 9th. The quick way to do this is how many times does 3 go in the 6? 3 goes in the 6 twice, so you're bringing out an a squared. 3 goes into 9 3 times, and it's b to the 3rd. Last, you have the fourth root of x to the 8th. And the fourth root of y12. So here 4 goes into 8 twice. 4 goes into 12 3 times. 3 is odd. Absolute values around it. So again, key is to know that if your index is even, and after you simplify, and your result ends up to be an odd exponent, you have to throw the absolute values around. You'll see that more as we do more examples. If you have any questions, see me before school, after school, or send me an email.